Today we're going to get into the probability of overlapping events. So we are going to be using something called the addition rule for probability. So this is when two things are happening at once and those two individual events have some overlap in them. And how do we account for that probability? So just remember, if E is an event, P of E stands for the probability that event E occurs. It is read as the probability of E. So we've been seeing this a while already. Visually, this is what it looks like in a Venn diagram. E would represent all the possibilities or the sample space. So like for a die, E would be 1, 2, 3, 4, 5, 6. All right, so we're going to get into specifically when we use the words and or the word or. So when we say the chance of event A and event B, which means both need to happen. So me grabbing a red marble, then grabbing a blue marble. When we talk about event A or B, is that the event where either A or B or both are happening. So for example, me grabbing a card that has either a spade or an ace, but both can happen at the same time if I grab the ace of spades. And that's where that overlap comes in, and we'll see a little bit more of that in a minute. All right, so we're going to talk about the combination of events. We've gone over the multiplication rule last week. Again, it was those and. When we say this, then this, that's where the and comes in. We use that multiplication rule for either independent or non-independent or dependent events. This is already in your notes. It's actually just kind of combined. And the or rule, this is when the addition rule when we have the word or. Again, this is a special case when events are mutually exclusive or not mutually exclusive. So we're going to really get into what does mutually exclusive mean, and that goes back to our overlapping and non-overlapping. So just visually, here's what it is. So let's say the second event, which is in the middle, where A and B intersect. So that would be where they both share common events. Whereas if I say or, it's the whole thing. So that's when I was multiplying on the right side. So the one what's all colored in, that's when we multiply. So all of these times all of those. But the middle one is where there's an overlap, and we have to really be careful with that overlapping of the event. All right, so mutually exclusive events. If two events are mutually exclusive, then they cannot happen at the same time. So when we say mutually exclusive, they are completely separate of each other. When one happens, the other one is not concurrently happening. So they are completely separate from each other. So like a die and a coin, they would have no outcomes in common. Whereas if they are not mutually exclusive, like the second picture where they overlap, that would be like an example of the left side being like the queen cards and the right side being the heart cards, while the overlap would be in the middle where the queen of hearts would be part of the event A and part of event B. So there would be an overlap in that case. So again, these are mutually exclusive events, write that in. And these are non-mutually exclusive events, write that in on your paper. Pause if necessary. So remember that middle section right here is the common outcomes. Back to the queen of hearts. If the left side is queens, right side is hearts, queen of hearts would be the overlap. Here's just examples of when we have more than two events happening, like three events. They can be completely mutually exclusive. They're all separate from each other. Rolling one die, rolling a second die, tossing a coin, or where they all can have something in common, or two can have something in common of the three. And this just gets a little bit more into it. So let's talk about the probability of multiple events happening. So let's find out, are these multiple events mutually exclusive? Do they not overlap? So mutually exclusive, they're separate from each other. So rolling an even number or a prime number on a number cube. So it really helps if you actually draw it. So I'm going to draw a Venn diagram here. Again, you don't have it on your paper, but just visually see what's going on. We have rolling an even number, so I can say we can roll 2, 4, or a 6. And then we're talking about prime numbers, which would be 2, 3, and 5 on a number cube. But again, these two share the number 2, so if I rewrite this, I would write it as this. They have the 2 in common, so it's a 2, 4, and 6, and this one has a 2, 3, and 5. So this would be the overlapping area right here. The number 2 is both an even number and a prime number, so these are not mutually exclusive. I'm just going to abbreviate. Let's look at the second example. We have rolling a prime number or a multiple of 6 on a number cube. So I'm going to draw them. So prime number again is the 2, the 3, and the 5. And a multiple of 6. The only multiple of 6 on the number cube is just the number 6. There is no overlap here, nothing in common, so these are mutually exclusive. So again, here's an example of events that are mutually exclusive and not mutually exclusive. Again, not mutually exclusive if they share something in common. All right, let's go ahead and clear this. And here we see it again verbally. So let's go ahead and move on. All right, so how to find the probability of two mutually exclusive events. So if they're mutually exclusive, then we have nothing to worry about. We just add how many of these and how many of those. So how many of sample A and how many of sample B. And then we just go ahead and add those probabilities. And we've actually done a few of these problems last week. Now for the second one, when they're not mutually exclusive, when you're double counting, you're still doing the P of A plus P of B, so event A plus event B. But you have to go back and subtract the one you counted twice, because if they have something in common, that means you're counting it once in event A and once in event B, which means you have to go back and subtract out the one you counted twice. So you subtract it once out. So again, you counted it once here. You counted a second time here. So you've counted one event twice, so you have to go back and subtract it once. So that's where this extra piece comes in. So you have to be able to decide if something is mutually exclusive, where you just add them, or not mutually exclusive, where you're double counting it, and you got to go back and subtract it. That's why we have to go ahead and do A and B. All right, let's go ahead and get started and see how this works out. All right, so let's go example 1. It says, a spinner has 10 equal sized sections labeled 1 through 10. Find the probability of each event. So we're talking about even numbers or multiples of 5. So is this mutually exclusive? So I'm going to talk about even numbers. Even numbers are 2, 4, 6, 8, and 10. And multiples of 5 would be the 5 and the 10. So do they have anything in common? In this case, they do. They have the number 10 in common. So visually in the Venn diagram, we would have the 10 here. We had 2, 4, 6, and 8. And then we would have the 5 here, and they share the number 10. So it's not mutually exclusive. Let me go ahead and put that back. I just deleted it by accident. So let me pause this real quick. All right, here we go. So now that we know that this is not mutually exclusive, let's go ahead and just write it down real quick. So it's non-mutually exclusive, so we're going to have to subtract that double count of the 10. So I'm going to find P of even. I'm just going to abbreviate as much as possible, plus the probability of event B, which is a multiple of 5. I'm going to put M of 5, or multiple of 5. And then I'm going to subtract the double count, which is E. And actually, let me just rewrite this somewhere off to the side because it doesn't fit. It should fit on your paper. Minus P of even and M5. So where they share the overlap. So in this case, my answer would be, change up the color. So it's going to equal the event A. The first event, there are 5 out of 10, because the spinner has from 1 through 10, and 5 of them are even, plus how many are multiples of 5? There's 2 multiples of 5 out of the 10 numbers on the spinner. And now we have to subtract the double count because we counted the number 10 twice. So how many are both even and multiples of 5, which are, there is 1 out of 10. So there is 1 repeat. So we got to subtract that out. So what is 5 plus 2? 7 minus 1. It's going to be 6 out of 10. The nice thing is you'll always have the same denominator, so you won't have to worry about that. And we just reduce this, so we're going to divide this by 2. We get 3/5 as our final answer. Let's go ahead and move on to number B. So we want multiples of 3 or 4. So I'm going to go ahead and write down the multiples of 3, which are 3, 6, and 9 from 0 to 10. And multiples of 4 are 4 and 8. So do they have anything in common? So these will not have anything in common. So these are mutually exclusive. So we have 3, 6, 9. We have 4 and 8. They have nothing in common. So here, for my probability, This is just P of multiples of 3 plus, let me actually put the M because it's not 3, multiples of 3. Actually, let's put it this way. Multiples of 3 plus a probability that it's a multiple of 4. There is no overlap. You can think about it saying subtracting 0. But multiples of 3, we have 3 out of 10. Multiples of 4, we have 2 out of 10, which means there's a total of 5 out of 10, which reduces down to 1/2. So half the numbers are either a multiple of 3 or a multiple of 4. Let's go ahead and move on to the next problem. All right, so we're going to look at the probability of picking a female or a person from Tennessee. So let's look at the left, Miss Tennessee, Georgia, and Alabama. So we want to see out of 31 committee members, so we have a total of 31. So if you were to add up all those numbers, we'd get 31. F is for female, M is for male. So let's go ahead and see that. Actually, let me go ahead and make sure we actually write it out. I think it's out of order. So we're going to find the probability. So P of finding someone who is a female or from Tennessee. So that would be the probability of finding females plus the probability of people from Tennessee. Now the question is, are they mutually exclusive? Is there overlap? So can a person be a female and from Tennessee? And the answer should be yes. So this is this section right here. This is where they overlap. So if you want to see the Venn diagram real quick, that would be this 8 right here. The 6 and the 7 would be, for other females, would be 6 and 7. And then for males would be 4, 3, and 3. So that would kind of be the female-male intersection. So I'm just going to go ahead and erase this. You don't need it. So let's go ahead and then subtract people who are both female and from Tennessee. So again, those who are from, probability that you choose a female. So females, we have a total of all of these right here. So that would be 21 out of the total of 31. People who are from Tennessee would be, let's see, these guys right here, 8 and 4, so there would be 12 out of 31. And then we're going to subtract where they're both female and from Tennessee is that intersection, which would be back where we had it circled earlier on the number 8. So there's 8 people who are both female and from Tennessee. So we are double counting them here and here, so we have to make sure we go back and subtract them. So what is 21 plus 12 minus 8? So that would be 25 out of 31. 33, yeah, and that's our final answer. So I'm going to stop the video here. You can do the rest of the examples on the next video.